Welcome, I'm Gksr from Department of Electronics and Communication Engineering. Today in this presentation, I'm going to explain the subject embedded system having subject code 18EC62. The topic for today's presentation is characteristics of embedded systems. Uh, First, we need to know that what are the characteristics of embedded system. The characteristics of embedded systems are given in the presentation that application and domain specific reactive and real time operates in harsh environment, distributed small size and weight, power concerns. These are all some basic characters of embedded system. In detail we will study in the next we will study in this presentation about this application and domain specific reactive and real time distributed and so on. These can be studied in detail in this presentation from the next slide. So moving to the next slide, application and domain specific. Each embedded system has certain functions to perform, and they are developed in such a manner to do the intended functions only. Mm, they cannot be used for any other purpose. For example, the embedded control unit of the microwave cannot be replaced with an air conditioner's embedded control unit, because the embedded control unit of microwave oven and air conditioner are specifically designed to perform a certain specific task. Also, an embedded control unit development for a particular domain, say telecom, cannot be replaced with another control designed to serve another domain like consumer electronics. Moving to the next application, reactive and real time. Embedded systems are in constant interaction with the real world through sensors and user defined inputs devices, which are connected to input port of the system. Any changes happening in the real world, which are generally known as event, are captured by the sensors or input devices in real time, and the control algorithm running inside the unit reacts in a designed manner to bring the control output variables to the desired level. Embedded system produce changes in output in response to the uh, changes in the input. So they are generally referred as reactive systems. Real-time system operate means the timing behavior of system should be deterministic. The system should respond to request or task in a known amount of time. A real-time system should not miss any deadlines for task operations. It is not necessary that all embedded systems should be real-time in operations. Uh, embedded applications or systems which are mission critical, like flight control system, anti-lock brake system, etc., are examples of real-time systems. Moving to the next application, operates in harsh environment. The environment in which the embedded system deployed may be dusty or high temperature zone or less temperature zone, or which may subject to vibrations and shocks. The embedded system must work in a harsh environment. System placed in such areas should be capable to withstand all these adverse operating conditions. The design should take care of the operating conditions of the area where the system is going to implement. For example, if the system needs to be deployed in a higher temperature zone, then all the components used in the system should be of high temperature grade. Also, proper shock absorption technique should be provided to systems which are going to be uh, commissioned in places subject to high shock. Power supply fluctuations, corrosion, and component aging, etc., are the other factors that need to be taken into consideration for embedded system to work in harsh environments. Mm, Moving to the next application, distributed application. The term distributed means that the embedded system may be part of larger systems. It is in the sense the we can get an example in the in the explanation that many number of such distributed embedded systems from a single large embedded control unit. For example, an automatic vending machine. It contains a card reader for prepaid vending machines, or a note scanner for these vending machines, a vending unit, etc. Each of them are independent embedded units, but they work together to perform overall vending machine. So that what in sense the vending machine contains many embedded systems which work their individual task and perform and connected all together to perform a vending function. Hope you understood the concept of vending machine. Uh, if not, we can take another example of ATM, automatic teller machine. It contains a card reader embedded unit responsible for reading and validating the user's ATM card. Transition unit for performing transaction, a currency counter for dispatching or vending currency to the authorized person or the provided or the person, and a printer unit for printing the transition detail. These are all some embedded units present in ATM machines. These are all work their individual activities in order to perform ATM function. We can visualize these as independent embedded system, but they work together to achieve common goal of providing money to the cash. This this is known as distributed. Hope you understood the distributed concept, application concept. And then small weight and size. Small weight and size. Product analysis is an important factor in choosing a product. For example, when you plan to buy a new mobile, you may compare to study or the pros and cons of a product available in the market. Definitely, the product as size, weight, shape, etc., will be one of the deciding factor to choose a product. People believe in praise. Small is beauty, so that. It is in the sense no one needs to buy the heavy mobiles, if the mobile is having about 2 to 3 kgs, no one will buy the sales of that particular mobile will be down. So it must be in a small manner. It must contain the small weight, small size in order to maintain a good look for the mobile. Um, so the weight and size is also matters in the embedded systems. Why only mobiles? Even if we will go in the flights, we can flights, the major issue is weight in the cabin. If the embedded system having 10 kilograms of weight at the tail, the f- the fuel burnt at the combustion is also increases. The entire flight range will decreases, and then the cost per person will increase. In order to reduce that, in order to minimize that pricing over there, we can the flights are using at most uh, less weight and size in the embedded systems used at the flights. Hope you understood this small weight and the size. And then moving to the next topic, power concerns. Power management is another important factor that needs to be considered in designing embedded system. Embedded system should be designed in such a way as to minimize the heat dispensation by the system. The production of high amount of heat demands cooling requirements, like cooling fans, which in turn occupies additional space and make system bulky. No one needs to buy an bulky systems, as the bulky systems will have more price to select the design according to the low power consumption, like low dropout regulators and controllers process with the power saving modes. Also, power management is critical concept in battery operated application. The more the power consumed, the less is the battery life. Hope you understood the applications of embedded system. Feel so great for presenting in front of you guys, and thank you. See you in the next video. Bye bye.